Hello, for this lesson we are talking about composite figures. Composite meaning multiple. So these are figures that are made out of multiple shapes, okay? And the reason that we're saying that they are made out of multiple shapes is because with geometry we've learned how to find the area of certain shapes such as triangles, parallelograms, trapezoids, okay? And so these shapes here aren't really, well, they're simply not any of those figures that we've learned how to find the area for. So we're going to utilize what we have learned and recognize, say, hey, if I look at this shape, I can turn it into multiple of the shapes I've learned how to find the area. That way, I can find the area of the entire shape, okay? So for number one here, okay, I'm going to say, well, what shapes could I turn this into? And if I connect here, right, if I connect that, I can see, well, this is a somewhat poorly drawn square, and this is a somewhat poorly drawn right triangle, okay? But so I need to find, okay, well, my formula for a triangle is area equals 1/2 base times height, right? So this will find me the area of my triangle. And so, well, I can find one of those values, it's 6. But I need this entire value, this entire line here, okay? Well, I know that this small portion here is 1. This other small portion here is 2. Well, I need the whole thing. Well, if this portion of the square is 5 inches, well then this one also has to be 5 inches. So this is 2 plus 5 plus 1 will get me the entire 8 inches. Okay, so that entire side of the triangle is 8 inches. So I could then plug those values in. A equals 1/2. 6 times 8. Okay, well that's going to get us 1/2 of 6 is 3. And 3 times 8 is 24. So the area of the triangle is 24 inches squared. Okay, well, then if I know that my square here, okay, my square is here, and, well, squares, I could use two formulas. I've seen it shown as A equals S squared, right? Because if it's a square, area equals the side times itself, okay? Or simply using the formula for a parallelogram, and that would be area equals base times height. Well, whichever one we're doing, it's going to be the same thing, because it's ultimately going to be A equals 5 times 5, right? Either of those formulas will find it, okay? A equals 25 inches squared. Well, if my triangle is 24 inches squared and my square is 25 inches squared, then I need to add them, and that will find me the total area. So it's 24 plus 25, and getting my total to 49 inches squared. Okay? Alright, for this one, this is a slightly different strategy, okay? So this is a, again, slightly poorly drawn rectangle. And for this one, it's missing a chunk of it. So we're going to use a different strategy for this one. Well, I can find the area of this entire rectangle, right? The rectangle, and that's a parallelogram, so I use area equals base times height. Well, the base is 36, the height is 20. 36 multiplied by 20, well, that's going to be 720 feet is what we're talking about this time, feet squared. Okay, but there's a chunk missing out of it, so we need to find the area of that triangle. And again, a triangle's formula, A equals 1/2 base times height. Okay, well, we're going to say our base is 6, our height here, it says it's 5. 1/2. So 1/2 of 6 again. Oh, gotta put parentheses to make sure that is true. 1/2 of 6 is 3. 3 times 5 is 15. 15 feet squared. Okay. So for this one though, okay, for this one, remember this 720 feet squared represents what would be the entire rectangle. Okay, including this. When we found this, it's saying we're missing 15 feet squared because that chunk is gone. So what we need to do, instead of adding like we did in this one, right? We added that shape to this shape. We actually need to subtract, because this value is the entire rectangle Well, we don't have an entire rectangle. We're missing a piece. So we take away. So we do 720 minus 15. Okay, and that's going to get us 705. And it is in feet. So feet squared. And that is our solution. So for these problems, you need to make sure you identify. Okay, first, what figures can I make this out of, right? Remember, these ones are ones you can't really do. We don't know a formula to find that shape in problem 1 or in problem 2. You need to identify what shapes, what can I put together to form this composite figure, right? In number 1, we said, okay, a triangle and a square. You know, you might have a trapezoid and a triangle. There are lots of different paths you can take. But you need to break it apart and then find out how to find the area of those things. Next, you need to remember, am I adding the values I find, like in problem 1, right? Because I have 2 shapes, I'm adding them together. Or am I subtracting, like in problem 2? Good luck on your lesson, and let me know if you have questions.